All right, you sick fucks, buckle up for our deep dive into the universe's ultimate shit show, black freaking holes. Seriously, you guys dumped a mountain of research on me, enough to form a singularity. I might need a Hawking radiation-powered backhoe just to dig through all this crap.
No worries, I came packing enough brain power for the both of us.
I'll just cut the crap and get right to it. So what the hell is a black hole? Besides, a cosmic garbage disposal that makes galaxies shit themselves.
More than just a garbage disposal, think of it like a warp in the fabric of reality. Like space-time got punched in the face, folded in on itself, and anything, even light, that gets too close, gone, sucked into the abyss.
Okay, well, a warp in the fabric of reality. That's some heavy shit, man.
Yeah.
So, like, if you trip and fall into one of these things, any chance of crawling back out?
Nope. Think of the event horizon, the point of no return, as a cosmic roach motel. Matter and energy check in, but they sure as hell don't check out.
Damn. So who the hell came up with this fucked up concept? Some pissed off astronomer just trying to scare the shit out of their students.
Well, the idea has been around for centuries, actually. This dude, John Michell, way back in 1784, came up with this idea of dark stars. Objects so massive their gravity wouldn't even let light escape.
So he was basically predicting black holes, like, way before we even knew what the hell they were.
Yeah, had the right idea, wrong physics. Einstein's theory of general relativity, that changed the game. But the funny thing is, even Einstein thought black holes were too bizarre to be real. Called them pathological solutions to his equations.
Wait, hold up. Einstein was wrong about something? I thought that dude was, like, the god of physics.
He was brilliant, no doubt, but even geniuses can stumble. See, his math predicted these things, but the idea was so out there that he just resisted it. Just couldn't wrap his head around an object so dense that nothing, not even light, could escape its grasp.
So what convinced everyone that black holes weren't just some theoretical bullshit? Did somebody finally spot one of these cosmic assholes in the wild?
Took a while. But the discovery of pulsars in 1967, that was a game changer. These crazy dense, rapidly spinning neutron stars proved that objects with extreme gravity, like, they could exist.
So pulsars were like the gateway drug to black hole obsession.
Exactly. Show that the universe could be far weirder and more extreme than we imagined. Black holes were suddenly on the table, not just some mathematical curiosity.
Okay, so we know these motherfuckers are out there, but just how big can they get? Is there like a weight limit for these cosmic photasses?
There's a thing called the Schwarzschild radius, which basically defines that event horizon based on the black hole's mass. And in terms of size, sky's the limit, dude. We're talking tiny ones, smaller than the moon, to supermassive ones at the heart of galaxies, billions of times heavier than the sun.
Billions of times heavier than the sun. My brain just blue screened. How the hell can something that massive even exist? Wouldn't it just, like, eat the entire universe?
Yeah.
Here's where it gets really interesting. Even though supermassive black holes have mind-boggling mass, their density can be surprisingly low. We're talking less dense than water in some cases.
Wait, less dense than water? Now you're just fucking with me.
No bullshit. It's all about volume, my friend. Spread that mass over a large enough area and boom, density drops. Think of it this way. A supermassive black hole, it's like a hoarder's paradise. It's packed with a shit ton of stuff, but it's not necessarily crammed into a tiny space.
Okay, so we got tiny ones, gigantic ones.
Yeah.
But how the hell do these things actually form?
The most common way is through, the grand finale of a giant star's life. So a star runs out of fuel, its core collapses under its own gravity, and that leads to this huge supernova explosion. Now, if the star was massive enough to begin with, the remaining core collapses further, and nothing can stop it.
Talk about going out with a bang, and then all that leftover star stuff gets crushed into a black hole. That's pretty fucked up.
Yeah, there's this thing called the Tolman-Oppenheimer-Volkoff limit. It's basically a cosmic weight limit for dying stars. If the remaining core after a supernova is above this limit, which is about 3 to 4 times the mass of the sun, gravity wins, hands down. No force in the universe can stop that shit from becoming a black hole. Game over, man.
Okay, so massive star goes supernova, the core collapses, and bam, black hole. Got it. Are there any other ways these things can pop up?
There are some wild theories about primordial black holes formed like in the chaotic mess of the Big Bang itself, and maybe some super high energy collisions could create them, but those are just hypotheticals. For now, we haven't actually observed those yet.
Primordial black holes from the Big Bang. So these things could be lurking around from the very beginning of time, ancient relics from the universe's like wild teenage years.
That's the idea. Finding one would be like winning the cosmic lottery. A glimpse into the universe's most extreme early years.
Okay, so we've got dying stars and possibly ancient black holes from the dawn of time. But here's a question that's been bugging me. If they suck in everything, including light, how the hell can we even see these motherfuckers? Isn't that kind of a paradox?
You're right, they don't emit light directly, but we can see the effects they have on their surroundings. Think of it like a cosmic shadow play. We can't see the puppeteer, but we see the shadows they cast.
Shadows, huh? So we're looking for what, like distortions in space or something?
We're looking for their gravitational influence. Black holes warp space-time, right? So they bend the path of light passing nearby. That's what we call gravitational lensing. And then there's the accretion disk. This swirling disk of gas and dust gets superheated as it falls into the black hole. That stuff glows like a motherfucker.
So we see the stuff falling in, getting cooked to a crisp, but not the black hole itself. Clever, but kind of roundabout.
Roundabout but effective. And then there's the Event Horizon Telescope. It's this network of telescopes that actually managed to image the shadow of a black hole back in 2019.
Hold the phone. They took a picture of a black hole. No way.
Way! Blurry as hell, but it's a real image. They captured the silhouette of a supermassive black hole against the glowing background of its accretion disk. Pretty fucking amazing.
Holy shit, that's mind-blowing. So we can see their effects, even take pictures of their shadows. Anything else? How else do we know these cosmic bastards are really out there?
Well, we can observe stars orbiting them. Their orbits tell us about the black hole's mass and location. And then there's the X-ray emissions. Remember that superheated matter in the accretion disk? It emits X-rays, which we can detect with telescopes.
So X-rays from something that doesn't emit light. This shit's full of contradictions, man.
That's what makes them so fascinating, dude. They break the rules. They push the boundaries of what we thought we knew about the universe.
Okay, so black holes warp reality, suck in everything that gets too close, and emit X-rays from the stuff they're devouring. But here's a question that's been bugging me. What happens to all the stuff that falls into a black hole? Does it just, like, vanish? Poof, gone.
That's the million-dollar question. And it leads us to one of the biggest mysteries in physics, the information paradox. See, in physics, information is never supposed to be truly lost. It might change form, get scrambled, but it's always there.
Right, like even when you burn a book, the information's still there, and the smoke, the ashes, it's just harder to read.
Exactly. But with black holes, it seems like the information just disappears. Gone, baby, gone. And that freaks physicists the fuck out.
I bet. So what happens to the information? Laws of physics, information paradox. This deep dive is getting deep, man.
It gets even deeper. There's this idea of Hawking radiation. Black holes actually emit this faint glow of radiation, and according to Hawking, that radiation carries away some of the black hole's mass over time. They slowly evaporate.
Wait, so black holes can shrink? I thought they were like the ultimate cosmic vacuum cleaners, sucking up everything in sight, getting bigger and bigger.
They do suck things up, but they also like slowly radiate their mass away. It takes an insanely long time, though. We're talking like longer than the current age of the universe for a typical black hole to evaporate completely.
So it's like a super slow leak. And the big question is, does that radiation carry the information about all the stuff the black hole ate?
That's the crux of the information paradox. Does the information come back out somehow, scrambled but still there? Or does it vanish into oblivion, breaking like the fundamental laws of physics as we know them?
Whoa. So what's the answer? Spill the cosmic beans.
Unfortunately, there's no easy answer. It's one of the biggest unsolved mysteries in physics. Some physicists think the information's preserved, somehow encoded in the Hawking radiation. Others think it's truly lost, and we need to rethink our whole understanding of the universe.
Damn, so we're left with more questions than answers.
For now, yeah. But that's the beauty of science, right? The unknown is what drives us to keep exploring, keep pushing the boundaries of our knowledge. And black holes, they're like the ultimate cosmic enigma, daring us to figure them out.
Well said. I don't know about you folks listening, but my mind is officially blown. Black holes are stranger, more complex, and more mind-boggling than I ever imagined, and we've only just scratched the surface.
We've laid the groundwork, explored the basics, but there's so much more to uncover. Welcome back, Space Cadets. Ready for more black hole shenanigans?
Hell yeah. Last time, we left off with that information paradox and Hawking radiation. My brain's still trying to process that mindfuck. But before we get lost in the existential abyss, let's talk about the different kinds of black holes. I hear size matters in the cosmic realm.
You got that right. Black holes aren't one size fits all. They come in a variety of flavors, from tiny to goddamn gargantuan.
Okay, lay it on me. What's the black hole size chart look like?
At the small end, you've got stellar mass black holes. These bad boys form from the collapse of massive stars, like we talked about. Typically pack a few times the mass of the sun into a space smaller than a city.
So, like, if one of those popped up next to Earth, we'd be screwed.
Screwed, squashed, and spaghettified, my friend. But don't worry, the odds of that happening are astronomically low.
Okay, good to know. What about the other end of the spectrum? You mentioned some real heavy hitters.
Ah, yes. The supermassive black holes. These are the titans of the cosmos lurking at the centers of galaxies, including our own Milky Way. We're talking millions or even billions of times the mass of the sun.
Billions. Holy shit. How the hell did those monsters form? Is it just a shit ton of stars collapsing at once?
That's one theory, but it's not the whole story. We think supermassive black holes grow over billions of years, swallowing up stars, gas, even other black holes. They're like the cosmic Pac-Man, chomping their way through the universe.
Cosmic Pac-Man. I love it. So you've got tiny ones, giant ones, anything in between.
You bet. We call them intermediate mass black holes, the middle children of the black hole family. They're not as common, but we're finding more and more evidence that they're out there. They probably form from the merger of smaller black holes or the collapse of supergent stars.
So it's like a whole family of cosmic beasts, from babies to grandparents. Makes you wonder what kind of Thanksgiving dinner they'd have.
Probably a buffet of neutron stars and dark matter with a side of Hawking radiation.
Sounds delicious. Terrifying. Okay, so we get the size chart down. What about their personalities? Are they all just sitting there passively sucking things up?
Some are chill, just hanging out in space, slowly sipping on the cosmic soup. But others are active, surrounded by these swirling disks of hot gas and dust, spewing out jets of high-energy particles. Those are the rock stars of the black hole world.
Sounds like those active ones are throwing some serious cosmic ragers. What makes them so energetic?
It's all about the accretion disk, that swirling whirlpool of matter spiraling into the black hole. As the material gets closer, it speeds up, heats up, emits all sorts of radiation. It's like a cosmic demolition derby, with matter colliding, radiating, and ultimately getting swallowed by the black hole.
And those jets you mentioned, are those like the black hole's burps after a big meal?
Kinda. They're beams of high-energy particles that get blasted out from the poles of the black hole. We're still not entirely sure how they form, but it's thought to be related to the magnetic fields around the black hole.
So active black holes are like cosmic particle cannons blasting stuff across the universe. That's metal as fuck.
Exactly. They can launch these jets for millions of light years, influencing the evolution of galaxies, shaping the structure of the cosmos. They're not just sitting there passively, they're actively shaping their surroundings.
Damn, black holes are even more badass than I thought. Okay, I gotta ask, what's the most mind-blowing, fucked up thing about black holes? Something that just makes you say, holy shit, this universe is insane.
That's a tough one. There's so much mind-bending stuff about black holes, but I'd have to say it's the way they distort time. Remember, they warp the fabric of space-time, and that includes time itself.
Time distortion. Okay, elaborate on that shit, because my brain is already starting to hurt.
Imagine you're watching a friend fall into a black hole. From your perspective, outside the black hole, you'd see their clock slow down as they approach the event horizon. They'd appear to move slower and slower, eventually freezing in time at the edge of the black hole.
So they'd be stuck there forever, frozen in time, like a cosmic statue.
From your perspective, yeah. But from their perspective, it'd be a completely different story. They'd continue falling, crossing the event horizon, and experiencing time normally. It's all relative, man.
Whoa. So time is literally different depending on where you are in relation to a black hole. That's some serious relativity shit right there.
That's what Einstein's theory of relativity tells us. It's one of the most mind-bending consequences of black holes. They literally mess with our perception of time. Makes you question what time even is.
All right, I'm officially mind-fucked. Time distortion, cosmic Pac-Man, particle cannons. Black holes are the gift that keeps on giving, even if it's the gift of existential dread.
But that's the beauty of it, right? Black holes force us to confront the limits of our understanding, to grapple with the truly bizarre and awe-inspiring aspects of the universe.
Well said. And we've only just scratched the surface.
Yeah.
There's so much more to explore, so many more mind-blowing concepts to unpack.
Exactly. Next time, we're going to go even deeper. We'll delve into the singularity, the heart of the black hole, where all the laws of physics break down. We'll talk about wormholes, the possibility of other universes, and maybe even touch on the idea of time travel.
Wormholes and time travel. Shit, you're not holding out on me, are you?
I'm just saving the best for last, my friend. Stay tuned, because things are about to get really wild.
All right, cosmic adventurers, welcome back for the grand finale of our black hole bonanza. Last time we left off with time distortion and the idea that black holes could, like, mess with our perception of reality. My brain's still a bit scrambled from that.
A little brain scrambling is good for you. Keeps those synapses firing. Now let's dive into the deepest, darkest part of a black hole, the singularity.
The singularity. That sounds even more mind-bending than time distortion. What's the deal with that? Is it like a tiny point in the center of the black hole where all the stuff it eats gets crushed into oblivion?
That's the general idea, but the truth is we have no fucking clue what's really going on in there. The singularity is where our current understanding of physics completely breaks down. It's where general relativity, our best theory of gravity, hits a wall.
So, like, it's the ultimate cosmic mystery box. We know it's there, but we have no idea what's inside.
Exactly. Some theories say it's a point of infinite density. Others say it might be a ring, or even something completely beyond our comprehension.
Infinite density, that's just insane. So if we could somehow survive falling into a black hole, which, let's be real, we can't, what would we see at the singularity?
Assuming our brains wouldn't instantly turn into cosmic soup, probably some pretty trippy shit. Some physicists speculate about wormholes, tunnels through space-time that could connect to other parts of the universe, or even other universes entirely.
Wormholes. Like shortcuts through the cosmos? Sign me up.
Hold your horses, space cowboy. Wormholes are still very much theoretical. We haven't actually observed any, and there are a lot of unanswered questions about how they might work, or if they even exist at all.
Okay, fair enough. But you mentioned other universes. Is that, like, a serious possibility, or just some wild sci-fi speculation?
It's definitely on the fringes of theoretical physics, but there are some intriguing ideas out there. Some theories suggest that our universe might be just one of many universes, a multiverse, and that black holes could be gateways between these different realities.
A multiverse. Multiple universes. That's some serious head-spinning shit right there.
It is, but it's also one of the most exciting possibilities in physics. Imagine the possibilities, right? Infinite universes, each with its own set of laws of physics, maybe even different versions of ourselves living out different lives.
Okay, no, my brain is officially melting. Infinite universes, wormholes. This is way more mind-blowing than I ever thought black holes could be.
And we haven't even touched on the possibility of time travel yet. Some theories suggest that the extreme gravity of a black hole could warp time so severely that it might be possible to travel through time.
Time travel. Now you're just messing with me.
Hey, I'm just the messenger. These are legitimate theories being explored by some of the brightest minds in physics. Black holes are like the ultimate playground for theoretical physicists. They push the boundaries of what we thought was possible and open up whole new realms of exploration.
So you're saying black holes are not just cosmic garbage disposals, but potential gateways to other universes, wormholes to distant parts of the cosmos, and maybe even time machines.
That's the beauty of it, man. We just don't know for sure. But the possibilities are mind-boggling. Black holes challenge us to think beyond our limited understanding of the universe, to embrace the unknown.
Well said. I think I need a drink after all this. My brain is fried.
Me too, buddy, me too. But hey, it's a good kind of fried. It's the kind of fried that makes you question everything you thought you knew about reality and leaves you hungry for more knowledge.
That's one way to put it. All right, folks, that's our deep dive into black holes. We covered a lot of ground today, from the basics to the truly mind-bending. Hopefully you've enjoyed the ride.
And if you haven't had your mind blown at least once during this episode, you're probably not paying attention. Black holes are some of the most fascinating and enigmatic objects in the universe, and there's still so much we don't know about them. But that's what makes them so damn exciting.
Damn straight. So next time you look up at the night sky, remember those cosmic monsters lurking out there? Warping time, devouring matter, and maybe even holding the secrets to other universes, and the nature of reality itself. Stay curious, folks.